Watch the front bumper of this modern luxury vehicle as it strikes a metal grocery cart at barely 5 miles per hour. The plastic cover absorbs the low-speed impact, exactly as it appears to design to do. But behind that flexible cosmetic shell, the slight inward compression instantly crushes $3,000 worth of hidden electronics. A tap in a grocery store parking lot now triggers a catastrophic repair bill. Insurance providers are looking at the math and refusing to pay for the repairs. Instead, they are declaring perfectly functional cars with zero structural damage complete write-offs over minor plastic damage, sending thousands of drivable vehicles directly to the junkyard. Later in this video, we will break down the exact trim levels you need to look for when buying a car to completely insulate yourself from this hidden financial hazard. To understand how a parking lot bump became a total loss, look at the front end of an older sedan like this. The design was purely mechanical, a thick plastic cover bolted directly over a rigid steel crash bar. You hit a pole, you scratched the plastic, and you moved on. Automakers have replaced that physical, impact-absorbing shield with a fragile housing for hyper-expensive, delicate technology. By moving the most sensitive components of the vehicle into the exact area most likely to hit a wall, they have shifted the entirety of the financial risk directly onto the consumer. The components sitting directly behind that thin plastic constitute the ADAS array, the Advanced Driver Assistance Systems. This is the hardware network responsible for your adaptive cruise control, lane keeping, and automatic emergency braking. Look closely at these intricate glass lenses and optical sensors. These are highly sensitive optical instruments built to aerospace tolerances, and they are completely exposed to the physical forces of the road. When the exterior bumper flexes inward by as little as half an inch, the physical pressure shatters the rigid mounting bracket securing these modules. The hardware cracks before the plastic even leaves a dent. You might assume the fix is simply buying a replacement module and plugging it into the harness. But a new sensor straight from the factory will not make the car safely drivable. This diagram shows the complex procedure required to activate the new hardware, a process called dynamic calibration. A specialized technician must park the car in a geometrically perfect, completely level room using a proprietary laser alignment grid to map the sensor's exact field of view to a fraction of a millimeter. The software trusts the physical angle of the hardware implicitly. If the calibration is off by a single degree, the car would misidentify a shadow or an empty adjacent lane as a solid obstacle, triggering sudden, violent emergency braking at highway speeds. Securing that microscopic precision requires highly specialized labor, which frequently costs more than the sensor itself. Placing highly fragile, precisely calibrated optical glass in the primary crush zone of a passenger vehicle guarantees extremely frequent breakage. Automakers operate on a specific economic model. The initial sale of a vehicle yields a relatively low margin. The massive, sustained profit margins are generated through the sale of proprietary replacement parts over the lifespan of that car. The million-dollar calibration rooms and proprietary lasers required to align these systems are entirely out of reach for your local independent mechanic. They simply cannot afford the equipment necessary to complete the repair. Because independent shops are locked out, every minor fender bender is forcibly routed directly back to the manufacturer's authorized dealership service centers. Automotive fragility serves as a highly efficient, engineered revenue stream. By monopolizing the repair tools, automakers ensure that every minor mistake on the road pays dividends directly back to their service departments at your expense. This dynamic bar chart contrasts the escalating cost of a minor accident against the actual market value of a used car. When a scratched bumper requires a new ADAS array, proprietary brackets, and hours of dynamic calibration, the repair bill rapidly approaches $8,000, pushing dangerously close to the static $15,000 value of the vehicle itself. The math forces the insurer's hand. Rather than paying the exorbitant repair costs, they write the policyholder a check for the value of the car. Perfectly drivable vehicles with intact frames and pristine engines are hauled off to scrapyards by the thousands every single month. The massive financial weight of these corporate write-offs is distributed directly to consumers. The soaring cost to repair hidden bumper technology is the exact mathematical reason your monthly car insurance premiums have skyrocketed over the last 3 years. The modern auto insurance model is failing because the numbers no longer balance. The system is being forced to cover aerospace-level calibration costs for the routine, low-speed traffic bumps that happen thousands of times a day. You can actively avoid this financial trap through a highly specific buying strategy focused purely on trim levels. When shopping for a used vehicle, the entry-level base models typically rely on basic cruise control, skipping the complex front-facing radar arrays entirely. A minor crash in a base model remains a cheap physical bumper repair. The fully loaded trims carry the fragile sensors and the massive financial liability. You can confirm a car's risk profile from the driver's seat. If the dashboard features glowing autonomous driving graphics, lane assist indicators, or complex heads-up displays, you are looking at concrete evidence of hyper-expensive hidden external sensors sitting right behind the front bumper. That consciously sacrificing a few minor autonomous convenience features on your next purchase, you instantly insulate yourself from an $8,000 repair bill and a totaled car. However, retreating to a base model or an older vehicle introduces a completely different, highly destructive mechanical danger. Deep inside your transmission sits a tiny piece of metal the size of your pinky finger. A common habit when parking places massive physical stress on this exact point, and if it snaps, your entire transmission is dead. Click the video on your screen to learn what you are doing wrong every time you shift into park before you cause a $4,000 failure.